All right, so I need to wrap up 9.7 from last night. We need to talk about the word problems of inequalities. So number 13. I do apologize for not actually hitting the record button for 9.7, but hopefully the notes were helpful. If not, I don't mind going through some more with y'all. But number 13 says a certain anesthetic must be administered in a way that requires the average dosage to remain under 450. So I want to be under 450 milligrams per hour in order to guarantee patient safety. This aesthetic is used during a 4-hour surgery. So we have 4 hours. For the first 3 hours, the dosage were as follows. So first 3 hours. So this will be our total. And in the first 3 hours, they totaled as 500 milligrams the first hour, 380 the second hour, and 520 milligrams the third hour. What must the fourth hour be to be under the 450? So this is like the average question. So this is the 500 plus 380 plus 520 plus that fourth hour that I don't know. So I'm going to call it X. I would divide it by 4 since there's 4 quantities. And I want to be under 450. So I want to be less than 450. Not less than or equal to, but less than. So in this case, I will combine like terms. Pull up a little calculator here. That's going to be 500 plus 380 plus 520. And I get 1400. So that'd be 1400 plus X divided by 4 less than 450. So just like we solved the equation one in 9.6, I'm going to multiply to get rid of that division since everything is being divided. So I get 1400 plus X is less than. So again, I'll pull up my calculator. We'll do 450 times 4, and we get 1800. I will then subtract 1400. And that gives me 400. So as long as I stay less than 400 milligrams, I will keep the average under 450. All right, so that's a type of problem that you'll see. So it's just like 9.6, but instead of the equal sign, it's just a less than sign. All right, and then the next type of question you'll see on number 14, it says Ashley is planning her wedding and is ordering flowered centerpieces. She wants some centerpieces and some lily centerpieces. The rose centerpieces cost $225. So roses cost $225. And the lilies centerpiece cost $175. If she needs a total of 20 centerpieces, we need a total of 20. And she has and she has a budget. So we have a budget of $3,900 to spend. What is the maximum number of rose centerpieces she can buy? So here's the thing. So we can buy 20. The roses cost $225. I don't know how many roses I can buy. So when I don't know something, I would do 225 times X. After that point, I would then add lilies, which will be 175. But if I don't know how many roses, I would take away from my total of 20. So in this case, that would be 20 minus my X. So I have 225 roses times my X, and then 175 times however much I have left for my lilies. So hypothetically, let's say I buy 15 roses, then this would be 20 minus 15, which would be 5. So I'd buy 175 times 5. This has to be less than my Let me fix this. This was 3,900 with a dollar sign. So it has to be less than 3,900. So then from there, I'm just going to solve it. So I distribute first. So I get 175 times 20. That gives me 3,500 minus 175x less than 3,900. Then from here, once I got rid of the parentheses, I can now combine like terms. So that is going to be 225 minus 175, which will give me now 50x plus 3,500 less than 3,900. I can now get rid of my constant. So I'll now subtract 3,500. So now I'll get 50x less than 400. Then I will finish off by dividing by 50. So I'll do 400 divided by 50. And I get 8. So I can, to stay under budget, buy at most, so at most, 8 rose centerpieces. All right, so if I bought more than that, it would go over. I can buy less than that, stay under budget as well, but I can buy at most 8 roses. So that's pretty much the end of 9.7. So now I want to get into 9.8, which is our last topic for this week, which is compound inequalities. All right, so I got 9.8, compound inequalities. So the very first thing we're going to look at is going to start kind of basic and then progressively get harder like the rest of the topics. But let's consider these two things. Let's say A equals the set of the numbers 2, 4, 6, and 8. And B represents the set of 1, 2, 4, 8. All right. These are just curly brackets. I think they're supposed to look more like this, but these just look like squiggly lines. I don't ever take off. That just represents a set of numbers, which is a list of numbers. And I want you to do two things. We're going to determine A union B. When you see this one, this represents or. And then I want you to do A intersection B. This would represent and. So this is union. This is intersection. For union, you're going to list all the numbers without repeating from least to greatest. So it can be in either A or B. So this ends up being 1, 2, you don't repeat, and then 4, and then 6, and then 8. So we basically list all the numbers. For an and, they have to have both in both sets. So I notice they both have a 2. So this would be 2. They both have a 4. So then it'll be 4, and they both have an 8. Therefore, or all of the numbers and only the ones that they both fall into. All right. So let's look at another one. Again, I want you to find the union and the intersection of these two guys. So M is equal to the set of -4, -1, 1/3, 5, 6.4, and 9. N is equal to -4, -3, -2, -1, and 0. So in part A, I want you to find the union. So I'm going to, not an actual U. It looks like a U. There you go. Union of A, I guess in this case it'd be M and N. So I'm going to list them all from least to greatest. So I have -4, -3, -2, -1. Again, it's already there. 0, 1/3, 5, 6.4, and 9. So all of the numbers. B, when I do the intersection, they share -4, and it looks like -1. So that would be its complete set. All right. We'll look at one more in this one. And again, you're going to find the union and intersection, but it's going to be presented to you like this. It'll say F is Y values such that. So when you see this bar right here, this means such that Y is a negative integer. And remember, integers are basically counting numbers and whole numbers greater than -4. So again, Y is a negative integer that's greater than -4. So it basically, instead of giving you the list, you have to kind of come up with the list yourself. So negative integers, so I'm looking at negative numbers that are greater than -4 would be -3, because again, this is like $4 in the whole. This would be $3 in the whole. This is greater than that. And then -2 and -1. Notice they're also whole. I don't count the fractions or anything like that. And I would stop there. 0 is not a negative number. So you have to kind of do this part on your own. And then G, should have maybe done the next page, is Y such that Y is a positive integer less than 4. So again, you have to do this part on your own. So positive integers that are less than 4, that would have to be 0. Oh, is 0 even considered? That's a good question. That's always at the neutral number in my opinion. So it might not be 0 at all. Yep, nope, 0 is not counted. So it'd just be 1, 2, 3. So those would be the positive integers that are less than 4. So when I come over here, this will be the answer that goes here. So by part A, if I'm looking for F union G, I'm going to list them all. So that would just be -3, -2, -1, 1, 2, and 3. And then my B would be my intersection, which would be nothing. They have nothing in common. So what we do is we write an empty set. Actually, hold on. Let me write this. So you can do it like this, where there's nothing in it, or write empty set. Either one works, but 0 would not be the answer. A lot of students want to put 0 as the answer. So it's either an empty set written in either one of these. All right. So now that's basically how you can find union or intersection or anything like that when given a set of numbers. So now what we're going to do is we're going to talk about how to graph these type of things. So on number 4, we're going to graph Y such that Y is greater than or equal to -1 and Y is less than 3. So remember, this right here has to be an intersection. So let me kind of clear this up for you. So here's my number line. If I go to -1, so here's 0. So here's -1, and then 1, 2, 3. You're going to graph both of these, but they have to only be what intersects. So what we've learned so far is -1 has a bracket, and then it's pointed in the right direction. So this will be a bracket, and I would shade this direction. So that's what this would be. And then, well, maybe a different green. I do 3, which is a parentheses shaded in this direction. So this is what it would naturally look like if you graphed them both on the same point. If it's an and, you're only going to consider the intersection. So therefore, what happens here is that your only answer then is from here to there and there to here. So we only do the intersection. All right. And that's all we have to do. So let's do another one with an or. So on number 5, we're going to graph t such that t is less than or equal to 8 or t is greater than 10. So let's look at that. So I'm going to start 8 right here and then go 9, 10. So we have something like that. All right, so to graph this, I start off with my 8. So it's a bracket and it's a less than. So it's going to go in this direction. And then I have my 10, which is the parentheses going in that direction. With an or case, it does not have to intersect. You just cover everything that it either works for this side or this side. All right, so that's what I was talking about last night. A and typically is like a sandwich case, so it's the in between, and an or case is what I like to call the wing case. They go in opposite directions, but that's not always true, and there are some examples that are not like that. But that for now, that's what I'm seeing on y'all's homework. All right, so let's get into the nitty gritty of solving these. So on number 6, to solve and graph, multiple things, solve, graph, and write in interval notation. So just like we were doing last night. But now the problems are going to look like negative 12 less than 5x plus 3 less than or equal to 8. So now what we do is these are the situations with compound. So focus on the middle. What would you do in the middle to solve? Hopefully you're saying, well, I got to get rid of my constant. So yes, I would get rid of the plus 3 by minusing 3. But now instead of doing it on both sides, we're going to do it on all 3 sides. So I have to subtract the 3 from the middle, the right, and the left. So I drop my 5x. 8 minus 3 is 5. And then negative 12 minus 3, you're going further in debt. So that's going to be negative 15. Then you divide, but instead of doing it on both sides, you're going to do it on all 3 sides. So that just gives me x. 5 divided by 5 is 1. 15 divided by 5 is 3. And then a negative and a positive make a negative. So there is your answer. So now we're going to graph this. Okay, so I have negative 3 right here. So negative 2, negative 1, 0, and 1. So this is negative 2 and negative 1. So I go to negative 3. It has a parenthesis. So I'm going to put a parenthesis there. And then 1 will be a bracket. So I'm going to put a bracket there. And since x is between these two things, I just shade between them. So to write it in interval notation, I get I get a parenthesis, negative 3, comma, 1 with a bracket. So there's your solution, there's your graph, there's your interval notation. All right, let's do a few more of these. So we'll do it right here. So number 7, we're going to do the same process. So I have negative 3 less than 5 minus 4x less than 17. So again, I got to get rid of the constant. So I'm going to subtract 5 on all 3 sides. Oh, got ahead of myself. So this would be 12. This would go away, and I'm left with negative 4x. And then this is negative 8. Then I'm going to divide by negative 4. So 12 divided by negative 4 is negative 3. This goes away and it's just an x. And negative 8 divided by negative 4 is positive 2. But I'm dividing by a negative, so I must flip the inequality. All right. Now this looks a little ridiculous because you have the largest number to smallest number. So I'm going to flip everything. So I'm going to rewrite this as negative 3 less than x less than 2. These two are the same answer, but this is the one that's going to win. So you still flip the inequality to get to this part, but then to write the answer, you need to flip it so that they're both less than. So you just flip the numbers back to the other side so that negative 3 is in fact less than 2. So then we're going to graph it. So again, I have negative 3, negative 2, negative 1, 0, 1, 2. And again, they both get parentheses. And then X is between those, so I'm going to shade in between. So then when I'm writing my interval notation, this will just be -3, comma, 2. Parentheses, -3, comma, 2, parentheses. And there's my graph, and there is my interval notation. All right, let's see if we can get a different one in. Let's look at number 8. Number 8 is 7 less than or equal to 5x minus 1 divided by 2 less than or equal to 13. So in this type, since I'm dividing the entire thing by 2, I have to get rid of the division first. So I'm going to do that by multiplying by 2. But what I do in the middle, I have to do on all sides. So 2 times 7 gives me 14. These 2 will go away, so I have 5x minus 1 left. 13 times 2 gives me 26. Now I can work it in. So this minus 1, I'm going to add 1 on all 3 sides. So 14 plus 1 is 15. And 26 divided by 1 is 20, or sorry, 26 plus 1 is 27. Then divide by 5. This will give me 3. This doesn't simplify any further. Oh, I don't have a 5 no more. So you can leave it like this, or you can write, so that's going to be like 5.4, I think is the decimal. I'm good either way. And that's a 5 on the bottom here. All right, so then to do my number line, here's 3, 4, 5, and 6. So there's my 4. So 5.4 would roughly be about right here-ish, somewhere right there. And because it has a line underneath it, it would get a bracket. And then my 3 would also get a bracket because it has a line underneath it. And then I just shade in the middle. So therefore I get bracket 3, comma, 5.4 or 27/5, doesn't matter to me, bracket. So you can also write it like this as well. All right. All right, so let's look at a couple of different cases as well. And then I think you would have enough examples. So number 9, you're going to be asked to solve something like this. So this would be -3x plus 5 greater than 8, or 2x minus 9 is greater than or equal to -1. This is not an option on which one you get to solve. You have to solve both. You just have to put them both on the same graph. So I'm going to solve the first one. So I'm going to subtract 5 on both sides. We get -3x is greater than 3. 5, by the way. Divide that by -3. I get -1, but have to flip that inequality. And then I'm going to come solve the other one. So then I'm going to add 9. So I get 2x is greater than or equal to 8. Then I'll divide by 2. And I get x is greater than or equal to 4. So you solve both, but you put them both on the same graph. So here's my 0. Here's -1. So when I graph this one here, it's a parentheses, and it's shaded to the left. And then I go 1, 2, 3, 4 right here. And this would be a bracket, and I would shade to the right. And so you basically put them both on the same graph. All right, I got one more, and then we'll call this one a day. So I got 4x minus 3 is greater than or equal to 1, or 5x plus 2 is less than or equal to 12. So I'm going to solve the first one. So I'm going to add 3 on both sides. I got 4x is greater than or equal to 4. Then I'll divide by 4. So that I get x is greater than or equal to 1. I think on number 9, they want new. I'll go back to this one because I have to write it in interval notation. So I'll show you how that looks as well. So I'll subtract 2. So I get 5x is less than 10. Divide by 5. So I get x is less than 2. So to make this graph, I would have here's 0, here's 1, here's 2. So 2 is a parentheses, and it shades this way. Here's 1 with a bracket, and it shades this way. So with an or, it doesn't have to overlap. So it would be the entire graph. So when it's the entire graph, to write this in interval notation, you would go negative infinity since the arrow is going to the left, to positive infinity since the arrow is going to the right. So with an or, it does not have to intersect. It can be the entire thing. So that's what I'm saying. They're not always wing cases like number 9. Sometimes you can have situations like this. The way you would do this answer is you're on the left side. So that would be parentheses, negative infinity, comma, to -1, parentheses, because that's what there is. And then we're going to write union, because that's what or is a union, bracket, or to positive infinity. And then we close it off since it's on the right side. All right, and then that pretty much wraps up 9.8. And then on Monday, we'll start 9.9, talking about absolute value equations. If you have any questions throughout this, continue to email me and I'll definitely help you out. Till then, I'll see you on Monday. Bye for now.